Sometimes people ask me whether we're doomed and the ice sheets are going to disappear whatever we do. Yes, the ice sheets are going to continue to lose mass. Sea level is going to continue to rise, but we still have control on whether it's 3 feet by the end of the century, or 5, or 7. So one of the consequences of climate change is sea level rise, and it's probably one of the greatest challenges that humanity is facing. It's important to keep in mind that the ice sheets are dynamic systems. They are formed by the accumulation of snow at the surface, which doesn't melt completely year after year, and this snow slowly gets more and more compressed and becomes ice. And then this ice, once it's thick enough, starts to move under its own weight. Ice sheet science is actually fairly new, so our understanding of how ice behaves, how it responds to climate change, is still a question mark. And there is a lot of research right now because it's the big unknown when it comes to sea level change. And so I'm using computer models, I'm using data from satellites to try to better understand what's happening in Greenland and Antarctica and try to reduce the uncertainty in these predictions. So far, if we look at why these ice sheets have been changing, we can say that the ocean is responsible for a lot of the mass change in Antarctica and about half of the mass change in Greenland. And what happens is, as these glaciers are affected by these warmer temperatures from the ocean, they retreat. And depending on the shape of the landscape underneath the ice, this retreat may be fast or may be slow. I realized that very quickly that the models were not going to do a good job unless we had a better idea of where we have canyons under the ice, where there are mountain ranges. And so I developed a new method to map the bed topography underneath the ice sheets based on simple physics combined with data that we get at the surface of the ice. And we discovered lots of features that we had no idea about. Deep canyons that extend for hundreds of kilometers inland. And that gives us a much better idea of which glaciers are vulnerable to climate change. So the work that I'm doing is to try to inform policymakers about what decisions lead to what outcome. If we look at Dartmouth, there is a lot of people interested in the Arctic and in polar regions in almost every department. So working on climate change, seeing firsthand the consequences of that, coming to Dartmouth felt like the right place to be. I'm Mathieu Morlighem. I'm a professor of earth sciences here at Dartmouth, and I'm a glaciologist. I study glaciers and ice sheets.